Hey, so this is kind of neat. Just yesterday, I went and I observed a fourth grade class. And in the class, they were doing 81 times 17. And the way that I learned that was you did 81 times 17, and you multiply 7 times 1 is 7. 7 times the 8 is 56. And then you put a 0 here for some reason. And then I'll change colors here. Boom. You go 1 times 1 is 1. And then 1 times 8 is 8. And then you go ahead and you add this up. And you're like, okay, I just did a bunch of multiplication, but I don't really know what that means. So I'm watching these fourth graders. And right off the bat, they draw this box. And I'm like, oh, what do you guys call that? Like, oh, it's an area model. I was like, okay, so what do you write down for this? Like, well, we write, instead of 81, we write 80 and then a 1. So instead of drawing out 80 or counting out 80, we're just gonna symbolize it with that 80 and then the 1. And then we're gonna do 10 and then 7 to get 17. And so they go 1 times 8 is 8, and then you have 2 zeros there, so it's 800. If you had 10 80s, you would end up with 800. And then 1 times 10 is 10. And then 80 times 7 is 560. And then 1 times 7 is 7. And then over to the side, they added up 800 plus 10. Boom, look at that. Plus 560 plus 7, 567. Boom, look at that. So that's where it was coming from. I'm like, wow, that's phenomenal. They're in fourth grade and they can do an area model or a generic rectangle or box method or whatever you want to call it. That's going to be great when they go to algebra and they got to do the purple problem, which is x plus 1, x plus 7. So instead of having 81, we have something in 1. We have x in 1. And instead of having 17 or a 10 and a 7, we now have an x and a 7. Notice that the numbers 1 times 7 still give you 7, but x times x gives you x squared, 7 times x gives you a 7x, and 1 times x gives you a 1x, right? And then you just kind of combine those all up, and the only things we can combine are along the diagonal here. 7x plus 1x is a positive 8x, and then we just write down the other things. So it's almost like your hundreds, and then your tens, and then your ones. So it's the parts of the problem. Instead of doing all at once and just worrying about what a final number is, you're finding the hundreds, the tens, and the thousands. Here we're finding the x squareds, then the x's, and then the numbers. And I was like, wow, that's so cool that these fourth graders know how to do that. So we're going to go ahead and try that strategy and take a look at a couple problems here that have some negatives today. So instead of doing 99 times something or 97 times something, you could do 100 minus 3. And that might be a way that kids do mental math. And if you had to do 97 times something, well, just do 100 times something and then do the minus 3 times something. And then here we have an x minus 4. So we've learned about exponents, repeated multiplication. X times x is x squared. Negative 4 times x is easy. Negative 3 times x is easy. And then negative 4 times negative 3 turns to a positive 12. I just combine up everything, and that gives me x squared. And then along that diagonal is now negative 7x and then positive 12. You may have learned the distributive property in middle school as well, which is x times x, and there's your x squared. There's your x squared. X times negative 4. There's your negative 4x. Negative 3 times x, there's your negative 3x. Those combine, boom. And then negative 3 times negative 4 is positive 12, and there it is. So you can get the answer multiple ways. Again, the way that I learn math, it might not be the way that you learn math. Maybe you want to be more visual. Maybe you want to go more old school. Maybe you want to do distributive property. Maybe you want to do the box method or the area model or generic rectangles, whatever you would like to call it. Cool, so I'll just take 1 second to write out those three things, just so you know what they are when we're talking about them. Or you can do like I did the arrows and do distributing. Cool, that was even called something different when I was in school, which is called FOIL. It would be the first in each group, then the outer in each group, first outer, then the inner in each group, that's the I, and then the last in each group, and that is where they came up with FOIL. But no worries, today we're going to focus on that visual model that hopefully you also learned in 4th grade, maybe if you had Mrs. Swanson. Cool, we got 2x and then plus 5, so I'm just going to put a positive 5 the same way I put a positive 2x. And I have 3x and negative 2. Multiply them, 2 times 3 is 6. X times x is x squared. Again, technically those are little multiplication signs, so if that helps you to break it down. 3 times 5 is 15, don't forget the x. 2 times negative 2 is negative 4, don't forget the x. And then 5 times 2 is 10, don't forget the negative. We go to write our answer, we've got 6x squared. We can always combine the diagonal, 15x minus 4x, that is a positive 11x, and then we've got our minus 10. Cool, you would get the same thing if you did the distributive property and you multiplied 2x times 3x, there it is. You get your x's there, you get some x's there, and your 5 times negative 2, there's your negative 10. All right, let's cruise through a couple more to, to finish off. If you feel comfortable, go ahead and move forward in the video, move to your check work, but we got x and positive 7, x and negative 2, that is x squared. 7 times x is easy, negative 2 times x is easy, and 7 times 2 is 14. Don't forget that negative. The final answer is x squared. Then I'm combining 7x minus 2x is a positive 5x. And then I've got my minus 14, so I have my final answer. Cool, so that's area model or box method or generic rectangles. Why are they called generic rectangles? Well, that's not actually 3x. That's not actually 4 inches or 4 centimeters. I'm just representing it, getting abstract in the mind a little bit. All right, x times x is x squared, and then there's a 3 out front. The 3 multiplies to the 6 to get 18, and don't forget the x after it. 4 times x, easy. 4 times 6 is 24. We've got 3x squared in that corner. I've got positive 22 x's there, and then a plus 24 at the end. Again, it's like my hundreds, tens, and ones digits. I'm just figuring out the different parts and combining them together. Box method, area model, generic rectangle. Again, area model, what's the quickest way to find the area of a room? It's to do the length times the width. So that's basically what I'm doing. It's like the length here is 4x minus 1, and the width is 2x plus 5. Maybe I had 2 beams and then an extra 5 centimeters. Or maybe it took 4 sheets of drywall, but then I had to cut off 1 inch, something like that. And then remember, we are multiplying polynomials. Poly means many. Nomials, I'm not exactly sure, I think means numbers or names. So you have multiple names or numbers. So we're multiplying 4 times 2. We can multiply numbers, and then we can multiply names or variables or letters. X times x is x squared. 4 times 5 is 20. Don't forget the x. 2 times negative 1 is negative 2. Don't forget the x. And 5 times 1 is 5. Don't forget the negative. Combine, I got my x squareds. I got 20x minus 2x, which is positive 18x. And then I have a minus 5, and there you go. There's a bunch of examples of multiplying polynomials using the box method, area model, or generic rectangles. If a 4th grader can do it, I believe that you can do it. We just got some x's and x squareds to take it up a notch.